Waves in the interior of the ocean, often caused by the tide that moves over sloping topography, increase the vertical transport of organic matter from higher in the water column towards the seafloor. Not surprisingly, such so-called internal waves have been associated to extensive benthic life, such as cold water coral reefs, in case studies. When investigated globally, internal tide generation is often interpreted in a depth-integrated sense. With idealized and realistic model simulations, we looked at the actual depth at which internal tides are generated on continental slopes on a global scale and related this to the depth of cold water coral occurrences. We found that the depth of internal tide generation decreases with intensified shallow stratification and, globally, shows a typical latitudinal depth pattern that correlates to that of cold water corals, especially in Northern Hemisphere autumn and winter. We further found that cold water corals are significantly more often situated on a topography where supercritical reflection of internal tide occurs than can be expected from a random distribution. These findings underline internal tide generation and the supercritical reflection of internal tides as globally important for cold water coral growth. The energetic dynamics of the internal tides likely increase the food supply towards the corals in the food-limited winter months. With an increase in stratification from climate change, the region of internal tide generation on continental slopes might possibly shallow, with consequences for cold water coral habitat.